Today we're going to talk about an article that came out a few weeks ago. A really interesting article that's based on two theories. A researcher combined these two things to make a new estimate of the age of the universe, and in fact, he simply doubled the age of the universe. But of course, it's not that simple, so watch until the end for a better understanding of this madness. Very well. First, this whole idea of the age of the universe is something really complicated. What do astronomers do to measure the age of the universe? There are several ways. One of them is essentially using the cosmic background radiation, calculating the redshift of galaxies and more, all based on the field equations of Albert Einstein's theory of relativity. From the equations of general relativity, you can essentially rewind as if you were dealing with the universe. You go back in time through the equations, and this aligns with what you observe. This is how astronomers determine what we consider the current age of the universe. Precisely 13,797 billion years, all based on a model called Lambda-CDM. What is this model? This model states that the evolution of the universe, the beginning of the universe, and everything else are governed by lambda, linked to dark energy, and CDM, which is cold dark matter, meaning dark matter and dark energy. They dominate the universe as we know it. It's a model with plenty of evidence that the universe began with the Big Bang. We don't know for sure, but many pieces of evidence exist, such as galaxies and observations like the cosmic background radiation. All of this leads us to our understanding of the universe's origin. However, many scientists are puzzled by some things observed in the universe. For instance, there's a star known as Methuselah, which, when you calculate its age, seems much older than the universe itself. But how is that possible? Some calculations indicate that this apparent contradiction is mainly due to uncertainties, but this star is one of the things that lead some scientists to entertain the idea that the universe is much older than the commonly accepted 13.797 billion years. And then comes the James Webb. The James Webb Space Telescope observed those galaxies. Remember those galaxies? The ones that created all that controversy? Now it's going to be even more challenging for those who believed the universe was younger. Here's what happened. Those galaxies there are about 300 million years after the Big Bang. According to some researchers, they exhibit a level of maturity and mass that should have taken billions of years of cosmic evolution. In other words, those galaxies there would have to have been born much earlier than the 300 million years after the Big Bang. Additionally, they are quite small in size, adding another mystery to this equation. So, a researcher named Rajendra Gupta, who is an associate professor of physics at the University of Ottawa, came up with an interesting theory. He used the theory of tired light, proposed by Zwicky, which suggests that the redshift of light from distant galaxies is due to the gradual energy loss of photons over vast cosmic distances. However, there were conflicts in the observations, and Gupta found that by allowing this theory to coexist with an expanding universe, it becomes possible to reinterpret the redshift as a hybrid phenomenon rather than purely due to expansion. What this guy did is really something. I'll leave a link to his article in the description for those interested in reading it. So, going back to the subject, that was one of the first things he introduced, Zwicky's tired light, where the redshift is due to this energy loss. But that alone wouldn't answer his questions. So he introduced another interesting idea to solve this problem. His idea is called coupling constants. This is a hypothesis created by Paul Dirac. He took an idea from Zwicky, who is a significant figure in cosmology, and combined it with Paul Dirac's theory of coupling constants to create his model. These coupling constants are fundamental physical constants that govern the interaction of particles. According to Paul Dirac, these constants might have changed over time. By allowing them to evolve, the time for the formation of the first galaxies observed by the James Webb, with a high redshift, could be extended from a few 100 million years, which is what he observed, 300 million years, to billions of years. This would provide a more plausible explanation for the advanced level of mass development observed in those galaxies of the James Webb. So when you do all these calculations, take what Gupta did, the coupling constants, and Zwicky's tired light, and give a new interpretation to the cosmological constant, you can recalculate the age of the universe. In this case, the universe wouldn't be 13.7 billion years old, but rather 26.7 billion years. In other words, the universe would be almost twice as old as we believed, considering all these things that Gupta put together. Remember, this is not a definitive result. I want to make that clear. But there you have it. His work has been published, a very interesting publication. I'll leave a link to it for you to download. Again, this article discusses the James Webb Space Telescope, observations made at the beginning of the universe, and the Lambda-CDM cosmology. In this article, he outlines all these modifications that should be made. But I ask you, does the universe really have nearly double its estimated age? What do you think? Leave your comments on this, and once again, read the article first. There's no point in complaining if you haven't read it. Remember that this is an idea. He's proposing it. Until this becomes a consensus in the scientific community, if it does, it will take time. But there's Gupta's idea about the age of the universe, considering these analyses he conducted. All good? This was the video I wanted to bring to you on this channel. I hope you enjoyed it. If you did, don't forget the YouTubeistic package. Share and subscribe to the channel if you haven't already. Leave your comments about what you think about all this.